So we left off ready to do range. That was the one thing we didn't get to on this problem. I thought we were going to make it. I really did. So, okay. We did domain. We talked domain before we got interrupted yesterday, right? Mm-hmm. So domain, how far left to how far right. And so as we were following, we went from -2 to 0, but then the graph picked back up here on the red. So then we went to 0 to 4. But then when we were ready to stop, we picked back up in the light blue and went all the way over to 7. So thus we ended up with the -2 to 7. Okay, range. Range is our y values up and down. So how low do we go? So as I start raising my pencil here, where's the first y value I hit?
-4.
Yeah, and we first talk about -4 here. That's our first y value. Parenthesis or bracket with that -4? Bracket. The dot is included, right? It's a filled-in dot, so it's a bracket. Okay, raising up, raising up. Where does this interval end? Yeah, we stop right here at this level here, which has a y value of -1. And in this case, we don't pick right up to anything else, do we? We can't just hop over to another line because there's nothing else at -1. Parenthesis or bracket? Parenthesis, because it is not equal to. So now, okay, when is the next time we touch graph? Okay, right here on my red piece, and that has a y value of 2. Now, we had this happen on the above one too, I think. What's happening? This piece at 2 is a horizontal line. Does it have any other y values besides 2? No. Okay. Does my blue line touch 2? Can I just hop to 2 on my blue line? No. So 2 is just going to be a standalone number. If you recall yesterday, I used brackets on the number up above. I'm going to use brackets, and it's going to be both brackets. I know I've had people want to say, oh, there's one of each, a parenthesis and a bracket. But it doesn't have to do with the endpoints there. It's the number 2 is included. The number 2 is shaded at some point in time or another. So it is included. And then, okay, keep going up. When do I next touch graph? At what y value?
2.5.
Okay, and that's the bottom of the blue line, which if you notice, it was between 2 and 3. We talked about that yesterday. It's at 2.5. Parenthesis or bracket on the 2.5. It's not equal to, so parenthesis, comma. How high does it go? We end at the y value of 3, and 3 has a bracket. Okay. I know, easy to do as a group. It's something you'll have to practice individually. Okay, but those are all the pieces. Okay, questions there? We're going to turn the page. Now we're going to reverse everything we just did. So yesterday we spent our time in this lesson. They gave us an equation and a blank graph, and we had to graph it. Now when you turn that page, they're giving you a graph, and we have to write the equation. So our job, before I turn my page, is to write something like this, where it's f of x equals however many equation pieces we need along with their domain, so like their intervals where they exist. Okay? So, piece by piece, okay? It just asks us to write a piecewise defined rule that defines the function in each of the following graphs. So, if you go back to the previous page, you'll notice it's kind of the format f of x equals, and we're going to fill in however many we need. Since I see 3 pieces of the equation, we can expect that I'm going to be writing 3 graphs, right, or 3 equations. I always start left and just work right. Seems most logical. I don't know that you have to, but definitely seems logical. And as we go through all these, I'm going to have us thinking y equals mx plus b. Okay? So let's start with this first piece here. I'm going to refer to it as my blue piece because I just made it blue, or navy blue, whatever. Okay, guys. If we're thinking y equals mx plus b, can you tell me the slope? Natalie?
It's like 1/1 negative.
There you go. Okay. So, and we can still think rise over run, yes? And so I tend to think down 1 over 1. So rise -1, run 1. What is -1 divided by 1?
-1.
-1. So we're going to have a slope of -1. I need a y-intercept now. What do I need to do to figure out my y-intercept? Thomas?
Would you just like imagine the line keeps going down?
Yeah. And I'm actually even going to do a little bit more than imagine. I'm going to kind of fill in some light dots. Okay, in other words, basically continue the line. If you can just visualize it, you know, if it's easy enough you can visualize, go for it. If you need to put a few dots in, go for it. But we just said we were going down 1 over 1. So if I continue from here, down 1 over 1, down 1 over 1, down 1 over 1. Oh, wait, did I just cross the y-axis? Yeah, where am I touching the y-axis at? 0. So I have a y-intercept of 0. You don't have to write this information off this side, but this is just my brain working. And what form did I say we're putting this in?
Y equals mx plus b.
Yeah, your goal is to think y equals mx plus b. So for this one, y equals, I could say -1x plus 0 if you want. But we're not going to really write y equals -1x plus 0, are we? What can we clean that up to be? Ian? -x. Do we need the 1 there? No, we can just say -x. Do we need a plus 0? No. So it's y equals -x. Now, when I get down here, keep in mind, f of x is taking the place of y. So I'm not going to put y equals -x here. I'm just going to put -x. And then, before we go too far, I want to go ahead and do our interval of x values. So as you look at that little short angled line, what are the left and right x values there? Does that make sense? So how far left and how far right this go? What's the left x value? -3. What's the right x value? -2. Are you with her? Those pieces line up with -3 to 2. Now, same formatting that you've been seeing, where I'm going to say -3 less than x less than -2. You can always use that formatting if you have the smaller number on the left, bigger number on the right, x in the middle, and then in that format, they're always both going to face the same and be less than signs. So -3 less than x less than -2. The one thing I didn't have us put on here yet, because I wanted you guys to do it, always stop and ask yourselves, do we need any equal signs? Do we need some equal signs?
Yes.
Where do I need an equal sign?
Between the 3 and the x.
Yeah, on the sign by the -3, because right here we have a filled in circle at -3, an open circle at -2, so that one doesn't need one. So just that left piece needs to become less than or equal to. Okay? Piece 2. Okay, repeat the process. I'm going to change colors just for some color coding here. Now we're going to this middle piece. Not sure that writing red on orange is the greatest idea, but that's all right. Thoughts about that line in the center? What do you think, Abby? Okay, there's no slope because it's a horizontal line. Well, technically there is a slope. It's a slope of 0. What else do we know? What's my y-intercept? 1. How can I write this line?
You just write 1.
Yeah, because if we were writing this, I mean, okay, yeah, you could say y equals 0x plus 1, but traditionally we just say y equals 1. Well, if f of x already equals the y, it's just the 1 here. Okay, so it's a horizontal line, y equals 1. On what interval? So what x value does that horizontal line begin at? And what x value does that horizontal line end at? Okay, right here at -2 to +1. So I'm going to write -2 less than x less than 1. You want to go ahead and throw the equals to in as you go? Awesome. I'm only not doing it because I'm teaching. Do we have any equals?
Yeah.
Yeah, there's one over here at -2 because it's a closed filled-in circle. The 1 is an open circle. And one more piece. Okay. Final piece here. Oh, that was horrible. What do you know about our third line that I'm making my green line right now? He says a slope of 4. Do you agree? Okay. So we're doing rise over run. So up 1, 2, 3, 4 over 1. So I can agree with that. 4 over 1 does give me a slope of 4. And we kind of have to start with 4 there because, you know, we hinted at earlier just visualizing it. This one I'd be a little more hesitant to just visualize just because I'm afraid I'd get off. So what are we going to do here? If it was up 4 over 1, then reverse it and go down 4, left 1. Where's that put me at?
-5.
Yeah, y-intercept of -5. So y equals 4x minus 5 for that piece. So down below, f of x is already there for y equals, and it's just 4x minus 5. On what interval? What are the x values?
1 to 2.
Yeah, 1 to 2. So 1 less than x less than 2. Do I need equal signs? On both, because they're both filled in. I know it's easy when we're doing it as a group, but you know how to do slope intercept. That's something you learned back in Algebra 1. Okay, we're reviewing slope intercept. So all these pieces you know how to do, you just have to take your time and do it. Okay, the only stinky part is it's very easy to make little mistakes. That's the rough part. Leaving out a negative sign or something, just, you're done. Okay, let's try one more for practice then. I'm going to set up f of x equals, and you will, in Savas, it'll always say, say f of x equals, and it'll have the braces here, and it'll have the boxes to fill in. What mistake did I make?
I think that graph is the same one that's the example on the front page.
Well, don't look at it then.
Ooh.
Oh, it is.
Don't look at it. Could have been I was struggling to find examples, so. Although the ordered pairs aren't listed there, so they must have had it somewhere else too. Okay, don't look at it. Shh, quit looking at it. You're getting ideas. I want you to do this without the ideas. Okay, first piece on the left. Disagree. I heard y equals 7.5, so I said disagree.
Oh, that's 6.
Yeah. It is an annoying graph, isn't it? Okay, so it counts by 2s, but then it only labels every 4. So feel free, this is 2, 4, 6, 8. So that is indeed at 7, isn't it? It is tricky, isn't it? I would love to say they won't do that in Savas, but
We don't know
It's
how
Savas.
soft it is.
it's Savas, and you guys haven't even met Savas that long, known Savas that long, but yeah. Okay, so horizontal line, you guys know, slope of 0 is just y equals 7. This problem continues tricky the whole way because of the counting, so just beware. What y interval is that? Or excuse me, not y interval, x interval. Do we like his answers this time?
With my brain, yeah.
Okay, so if I label these lines, that one's definitely at -2. That first one is between 4 and 6, so yep. -5 less than x less than -2. Would you like any equal to signs on your inequalities? Yeah, they are both closed filled in circles, so I want equal to signs. Okay, middle piece. I like this middle piece. I'm not going to have, in terms of I'm not going to have to guess on the y-intercept or anything. I think the hardest part of these is slope, honestly. Okay, thoughts? It says -x plus 5.
Give my brain.
Give your brain a moment. Okay, what about the 5? Can we agree with the 5?
Yes.
Yeah.
That's the easy one to see here, isn't it? Because you've got 4 and 6, y-intercept in the middle. We do have a y-intercept of 5. Okay, now, the slope is the frustrating part here, isn't it? Because you're trying to count and there's no nice neat dots to count. Other than, I mean, you could if you want to, well, yeah, it's 1/1. If you just look at, okay, everything's counting by 2's, isn't it? So when you go half a box, you're really going 1. So if I go, say, down 1, right 1, down 1, right 1 is -1/1. Excuse me, -1. Now, you could also, I've seen some people do this, they just count all the way down. If this is at a 7 right here, yes, and this down here is at a 2, what is that? 7 to 2, you're going down 5. I'm just giving you an alternate option here. And then if you go from here over to here, you're going from -2 over to 3. -2 to 3 is a distance of 5. Does that help? If you didn't like those half pieces? I mean, you still have to deal with the half pieces, but -5 to 5, well, guess what? That's still our slope of -1. So, what's our equation? Y equals what did I do? Why do I have a 0 in there? I know we said 5. Don't ask that. Okay. Y-intercept is indeed 5. We said it. I'll blame it on the pin. The pin wrote it wrong. So, -1x plus 5 or -x plus 5. We just talked about the x interval. Where does it go? -2 to 3. So -2 less than x less than 3 and equal signs
Both.
on both. Third piece. Okay. Well, we're going to have to start with the slope. What do you think, Ian? I think I side with the 2's if I recall.
Yeah.
Now, ways to do this. Okay, we could, if we start from down here and we rise 1, 2, 3, 4, or you're rising from a 5 to a 9, so that's a rise of 4. If you run, you're running 1, 2, you're running from 4 to 6, which is a run of 2. 4 over 2 is 2. You don't like that the graph got you, do you? Okay. Y-intercept. We have a slope of 2 here, yes?
Mhm.
And so you can count like a down 4 over 2, since that's what we had, or I'm just going to go down 2 over 1. So if I go, okay, so here we are, down 2 over 1. Down 2 over 1. Down 2 over 1.
Oh, I did this.
Down 2 over 1. Well, the question is, did I do it right? Because I messed it up this morning. Does that work?
Yeah.
I got confused and started using a slope of 1 from a different problem, or from the previous part. Okay, so right there, we do end up down at -3. Okay, I'll be honest, I forgot and I started using the slope of -1 from the previous portion, but when we looked at my line, besides the fact everyone knew I was doing it wrong, my line didn't go straight. It was like, it was an angled line. And so that was an immediate point of, yeah, I did something wrong. So, okay, what'd you write down here? 2x minus 3 on what interval? You guys agree with that? It's between 4 and 6, and 6 is filled in and equal to. Yep. Yes.
It wouldn't be 2 because each unit is 2 units. It wouldn't be 2x because you're going down by 2 each line.
But then you're going over 1.
It's 4
Yes,
over
it would be
2.
4 over.
It's 4 over 2, which makes it 2.
4 over 2 reduces to 2. That's what I went with.
Yeah, so okay.
I mean, you can still
Yeah.
count 4 over 2, but if you
But
put
I
4 over
counted
2 in SOLVE as 4 over, they're going to count it wrong.
I had counted it as 4 over 1.
Okay, that's a problem.
Which is why I had 4.
Again, this is why I do not like when they have graphs count by 2, because they just confuse us. Now, on the flip side, is it good for us to learn how to deal with a graph like this? It is. Whether we like it or not, it's good to learn how to deal with a graph like this, get all of our mistakes out now. I'll also tell you, I will try my best to avoid putting something like this on a quiz or a test. I can't guarantee homework, okay, but I will try my best. And I can't even guarantee anything because sometimes it's just hard to find examples. But I will try and keep them counting by ones when I'm assessing you. So, okay, 2 more examples. These are the easy part, actually. I know some of you are saying a word problem is easy. Yes, it is, actually. In my brain. Okay, I'll lead you, though. So, I feel like this is kind of an outdated scenario, but that's all right. A phone company offers a monthly cell phone plan for $25. The plan includes 250 anytime minutes and charges 20 cents per minute above the 250 minutes. Write a piecewise defined function for C of x, the cost for using x minutes in a month. Okay. We're writing an equation like what we just did. Okay. Normally we start with f of x. This time I'm going to start with c of x. So you got the first part. So c of x equals, there's my little piece. Okay. C stands for the cost of a phone in terms of x, so in terms of minutes. What's a cost you could pay for that phone? Basic. What could be your monthly cost?
25.
Could you just pay $25? Yes. So one of my options here is that I could just pay $25. On what interval? When do I pay just $25?
250 minutes?
Or
0 to 250?
Less.
less, okay? So 0 to 250 minutes, because anything, we're not going to say negative, that's why we're going to not just say less than 250, we're going to go 0 to 250. Or we're going to say 0, less than X, less than 250. Now, in terms of equal tos, is 250 included here? Yes, because it includes 250. So you can go up to 250. 0, you could kind of go either way, but if we're 0, we're not even, we're going to assume you at least have a minute, I guess. Okay? Now, okay, so that's for 0 to 250 minutes. Now, what's my other option of what I might possibly pay?
20 cents.
Okay, so we could be paying 20 cents. What is it, though?
Above the 250.
Okay, when you're above the 250, it's 20 cents per minute. How many times am I paying that 20 cents?
Amount of time.
Okay, for every minute, which what are minutes? X. Okay, we're talking X minutes. So that next bill, if I go over, I'm paying 20 cents per minute because I go over. Plus I have to pay what else?
The 25.
The 25. So you've still got that 25 cost plus 20 cents per minute, or in other words, 0.2 times X. Okay? When am I paying that? On what interval?
When you go over 250?
When I go over 250. So, and there's no cap on this, is there? It's not like 250 to 500, there's no cap in this problem. So just X greater than 250. Do I want equals to? No, because equals to was on the previous part, right? Okay, so that's a word problem scenario. It's just breaking into the pieces when you have an interval there. Okay, one other piece. And I know you're saying, oh, another graph, but I kind of think this is the easy graph once you understand it. Okay, compared to the others, this one's less work. This table represents the fees for a parking lot, or in my brain, I think parking garage, but graph the function. What are the domain and range of the function? So, okay, look at the information provided. We have time intervals and costs. So for 0 to 3 hours, I'm going to pay $10. 3 to 6 hours, I'm going to pay $15. 6 to 9 hours, I'm going to pay $20. 9 to 12 hours, I'm going to pay $25. On my graph, you'll see I have a t-axis, and t is my time, right?
Mm-hmm.
And if you notice, it was time in terms of hours if you want. What's that mean my y-axis is? That is going to be my cost. And that cost is in terms of dollars. Okay, look at that first piece. Think about how we're going to graph this. From 0 to 3 hours, I'm paying a $10 charge. So flat $10. What are you thinking?
Just straight line.
Straight line, because it's just it's just $10, not going up or down on that interval. Where am I drawing that straight line?
From 0 to 3.
So at $10, I'm going to draw a line from 0 to 3. Endpoints? What do you see, Michaela?
On the 0 is going to be the first one that's going to be open, and then close.
Because at 0 hours, well, we're not including 0 hours because You're not paying, you're never going to park for 0 hours because you didn't even go in then. 3 hours is included here. Okay, next piece. Now, 3 to 6 hours, I'm going to pay $15. So what do you see, Addie? Okay. So now we're going to jump up to the 15 line. Again, it's another flat line. Going from 3 to 6. Endpoints of open and closed again. Okay, that's just saying at 3 hours exactly, you pay $10. At 3 hours and 1 minute, you pay $15. Okay, you continue and you see the pattern here? Now at $20, I'm going to pay $20 from 6 to 9 hours. So start at 6, end at 9. At 6, I need an open circle. At 9, I need a closed. And finally, I'm going to pay $25 now. $25 from 9 to 12 hours. 9 hours is open. 12 hours is closed. Okay, so it's another piecewise function. It's a common one to see in math. Kind of looks like stair steps if you think about it that way. Okay. And now we need to talk domain and range. Okay. Thoughts on the domain? Remember, domain is reading where?
Left to right.
Left to right. Okay, just checking that. What are you thinking, Zach?
Would it just be 0 to 12?
What do you guys think? Ian?
Parentheses 0, bracket 2.
Okay. Parenthesis and bracket, 0 to 12. Okay. As we start here, and we start here at 0, we have a 0. It's not included, so we will think parenthesis. And then as we get over here to 3, what happens? This line stops, but another line picks up at 3. This dot's filled in, so as long as one of the dots is filled in, we get to just keep going. 3 to 6. Oh, but there's another line that starts. 6 to 9, and then there's another line that starts 9 to 12. So we are going all the way over. 0 to 12. 0 was not included. 12 was filled in, so it was included. Okay, range. Now we're going low to high. A little bit different here, I don't know. Addie?
10, 15, 20, and 25 in brackets.
Okay. I'm actually going to write it slightly different. But do we have numbers in between? No, we have 10. We have y value 15, 20, and 25, right?
Mhm.
If you guys go back to, I don't know if you remember how you first wrote range like back in middle school when we were just listing numbers. But when we had a list of numbers, we usually use, it's a brace. I call it a squiggly parenthesis also. Okay, we list just a list of numbers. So 10, 15, 20, 25 is officially how they have that done. Which that's what I thought about doing when we had just a single number previously. I thought about using those as well, but I went with brackets because I think that's what the book did. So, okay, guys. You have lesson 1.3 in Savas. You guys have like 9 minutes if you want to get in and look at it. Okay. Savas scores did go in the gradebook today. So gradebook is up to date as of actually last period. Yeah, so this homework will be due on Monday.